Okay, a very good morning or good afternoon, depending on your time zone. So I'm Dr. Liu Junten. So today, for International MEITA IoT Challenge, I'm going to teach you all a little bit about how to do analytics. So in this case, we're focusing on the Peat data analytics because this will be the case study or also one of the um, key project in our MEITA project. So, okay, without further ado, let's us look into what's the outline of this video. So for this video, first of all, I will talk a little bit about the case study. So the basic info about the case study, for example, like how do we get the data, how do we collect the data, and then uh, the site of the study. After that, we'll look into the software that we are going to use. We're going to teach about in this video. So in terms of the software, so we are going to look into what is Anaconda, what is Jupyter Notebook, and so on. Then followed by get the data. So how do we acquire the data, import the data into the code, and then how do we visualize the data to get some information out of it so we can get better understanding, and how do we gonna play around with it before going into prepare the data. Prepare the data means that because when we do a data analytics, the data may not be how we want it to be. So there's a few processes that we have to do before we even conduct the model training. So after we are done with the data preparation, then we can proceed with the model training. So you have to select the model that you wish to use, for example, like linear regression, decision tree, and different classification, and then maybe even more advanced techniques such as deep neural network, CNN, reinforced learning. So it depends on what kind of tools that you want to use. And then in this class, because I just want to show you the basic flow on how we work on data analytics, so we'll just go with the most basic one, which is the linear regression using machine learning. And lastly, after you have trained your model, after the model has learned how to predict, then we will look into how do we analyze the performance of the model trained. So this is the basic outline of today's video. So let's look into it. So first is the brief info about the site study, which is the RMFR, Raja Musa Forest Reserve peatland. So you can see on the slide is the site of study. So Raja RMFR is actually quite wide. And then based on our past experience and discussion with the local authority, we know that if the water table drop beyond a certain level, there's a high possibility of fire risk. So in order to avoid that, we must be able to predict the trend of the water table so that we can avoid the forest fire from happening. Because according to the Forestry Department of Selangor State, they mentioned that every year they have spent millions of ringgit in order to repair the damage caused by the forest fire. So what we do here is that we're trying to set up a IoT system to collect the data from the piezometer, which help us detect or measure the water table. And then all this collection, this sensory data will be uploaded to the cloud. So the piezometer is set up on the ground sensor, and then it will transmit all the collected data to the lookout tower, as you can see on the top right picture. So this is the lookout tower, where on top of the lookout tower, we have actually installed the Lora gateway in order to serve as like a data aggregation point, so that all the data collected will be accumulated here and then forwarded to the cloud. So at the bottom right of the slide is actually the peat swamp area in the IMFR. So you can see that it's actually very hard to work in. How do I say? It's very difficult to reach the deeper part of it. So installing this kind of applications such as the IoT network actually help us to measure the water table without facing the difficulty of going into the peat swamp every time when you have to know the condition of the peatland. So that's the main objective of the project. So okay, so this slide shows you the basic layout of the IoT system. So you can see that SN1 is the sensor node 1, sensor node 2, and then in the middle is the lookout tower, the tower location. And beside the LoRa gateway, we also install the weather station on top of it and the camera in order to safekeeping the gateway and also the installed weather station. So apart from that, we also have an actuator node for water pump, but for today data analytics class, we are not going to look into that. We're just going to focus on the data collected from the sensor node and then transmitted to the gateway, and then what will we do with the data collected when we have the data. And at the bottom right is the overall layout plan of the deployed IoT system. As you can see, how does it looks like for each component. So this is actually the ground sensor node. So on top of it is the LoRa node and sensor box, and then it's connected to the piezometer, which is actually like a pipe buried deeply into the soil, because they use a professional tool to drill into the pit, and then so that we can install it and deep enough in order to measure the water table. So on the right side of it is the observation tower or lookout tower. This is the LoRa gateway, and then the weather station, where it can help to measure the ambient humidity, ambient temperature, the wind speed, wind direction, and so on. So this data collected by the weather station will also be used in our data analytic process. So now let's look into the software that we're going to use. So in terms of software that we're going to use is actually the most commonly used or the most famous Python tools, which is Anaconda. And then inside Anaconda, there's a lot of different programs that you can choose from. For example, like Orange, Spider, Notebook, and so on. But we are going to look into how to use this the Jupyter Notebook, which is the most commonly used platform to do Python programming. So it's actually very important for you to master how to use Python because in nowadays the job market, so a lot of them, if you are interested to go into the software programming, so a lot of company will ask for Python skill. So I recommend that try to at least understand how it works, and then learn it if you can, and then it will really help you, because not only in terms of engineering, but a lot of data analysts or consultancy, they are making use of Python as well. So it's very good if you can know how to use it. So this is the basic layout when you click on the Jupyter Notebook. So it will bring you to a web page. So then you can try to do coding. So you just click on the new, and then select Python 3, and then it will open a notebook. So how does a notebook look like? So notebook looks something like this. So you can see that this part is the title, and then some basic panel, save, copy, paste, and then unlike the programming software that you guys are probably used to before this, such as MATLAB, C++. So the unique point about Jupyter Notebook is that the coding is go by cell. So you can see that each gray block of this is actually called a cell. So when you run the code, you don't have to run everything that you have wrote. So it is very helpful for you to debug, because you can just run block by block or cell by cell. So maybe you just want to try out the first cell, so you can just press Shift Enter, and then it will run the first cell without going through the remaining of the code, because you maybe have an error at the third cell, then you might not it might not be beneficial. So you can at least know that cell 1 and cell 2 is work, but cell 3 is not working. So it is very good for debugging because it helps a lot. And besides this, Jupyter Notebook is very good for documentation as well, because beside running it as a program, you can also change it to markup. Markup mode, you can try to type some notes, some documentation that help you to remember or help you to explain the things. Because I have seen people that actually use Jupyter Notebook to actually write a book, so which is very interesting. So try exploit around. So beside using it as a Python code running tools, maybe you can try to use markup as well for documentation, because it will goes a long way to help you to blend, to prepare yourself to work as a team, as a programmer or engineer in future. Okay, so basically that's it about our the software that we're going to use. So now, data analytics is very common nowadays. You heard everyone say about it all the time, but uh, what is the process? So the first step of data analytics is always get the data. You have to have data before you can proceed to analyze and do data analytics. So this is always a first step, get the data. So how do we get the data? So data and data analytics come in different format or source. One of the common format you maybe heard of is called JSON. And then in this class, we'll be using the .csv. The CSV file is something like an Excel file. So everything saved in terms of row and column. So then you can just it seems it's like an array. So then you can just fetch it from the CSV file, and then you can do wonder with it. You can do whatever you want with it. And then so I'll show you later in the example later. So web scraping is also a method for you to get data. So web scraping is actually means that you go to a website and then you inspect its source code and then try to get some of the data you want from the website. For example, you might be interested in the number of followers of the most known people on Twitter. So then you might want to collect this data from Twitter, but it is infeasible for you to like go in, copy, and then jot it down yourself every time. So one of the way to do it is called web scraping. So this is another huge topic, but also a very interesting method that you guys can look into. And .txt file, you can also get your data from the .txt file. But in this training, we're going to focus on Peat data collected by the IoT system, which is actually saved in the .csv file here. So how do you get the data? So get the data is very easy. You just have to use read.csv. So read.csv is actually a command from for Python from Panda. So before you can use it, similar to like MATLAB and C++, you must call the library first. So you have to import all this, import NumPy, import pandas, matplotlib for you to plot the graph, and then this is the basic process that you have to do before you can start to fetch your data into it. So in the third cell here, you can see that I use pd panda.readcsv. So this is the CSV file that I'm going to read, and I save it as a data frame. And then I use the data frame .head, a command to print out the first 5 rows of the data frame. So you can see the first 5 rows, how the data look like. So this is how the data look like. We have like date time, the water level collected by the sensor, the humidity, what is the SNR of the Lora node, the RSSI, the soil temperature, and then what's the water level difference. So all this data is actually saved in a .csv file. But after you have read it into the data frame, then you can start conduct or do whatever data processing that you want with it for your data analytics and model training later. So after you get the data, what is the second step? The second step is usually data visualization. Why? Because when you already have the data, you don't know much about the raw data. So you have to visualize it for you to get some information or get some understanding on it. So here I share a few simple comments that you might want to use when you do your own data analytic project. So first is the .head. as you can see on the cell here. So dot hash print out the first 5 rows of the data frame. So you can see how it looks like. Then the second command is dot describe. So dot describe is actually shows a summary of the numerical attribute. So when you use dot describe for each attribute, you can actually see how many in so what is the mean, what is the standard deviation, what is the minimum value, max value. So this is very useful because when you do when you conduct data analytics, so sometimes there are a lot of different characteristics or different features or attributes. So for example, in this case, water level. So you have to know what is the basic characteristic of water level. For example, if the max goes beyond certain value, then it might not be logic. Then you know that something is wrong with the data. So then you have to work on it and find out what's the problem, or maybe remove the faulty input or the faulty data. So describe is actually one of the first step that you should do whenever you get the data. So it give you the basic idea of the data that you have, help you to pinpoint some of the most obvious problem that you might miss. Because in this case, you can see that we have like 1,762 entries. So it is very tricky and very time wasting and illogical for you to go through all this entry yourself. So using the scribe here, you can actually get a basic idea to see that if there is any outlier or any inaccurate, illogical values that that you have collected in your data here. So dot describe, very useful. Next is the dot info. So dot info, you get a quick description of the data, in particular the total number of rows, each attribute type, and numbers of non-null values. So yeah, so dot info is something that you have to use as well, because it get you the idea of what is the attribute type. For example, if you want a certain attribute to be in integer, so then you have to work on it. So this shows you what is the attribute type for all the attributes in the data. Okay. So then plot the graph. So graph is also one of the very common method that we use in data visualization. For example, in this case, what I plot is the water table of the sensor node 1 and sensor node 2. So you can see how is the basic trend here. You can see that the water table usually decrease a little bit, go up, decrease, and go up. So this may be due to this may be just due to this seems like a normal process here. So you can see that, okay, this seems like a normal process, and suddenly around 30th of January, you see a huge increase to the water level. So what can we get here? So it is logic for us to make a guess that maybe on this day it happened to be raining, so the water table increased, so we get a higher water table. So then perhaps you might want to check on the weather record to see if rainings really happened on that day. So graph is a very useful tool for you to visualize your data as well. So on top of the slide is that I'll show you how can you do the graph plotting using Python here. Then another very important tool that I wish to highlight is the scatter plot. So scatter plot is actually a graph plotting method to show the relationship between three attributes. Okay, so when we plot the scatter plot, you will see all the data entries will be shown. So there's a few trends that you might see. So if it is straight lines, mean that they are very closely related, directly proportional. So it means that they have good correlation. Yeah, good correlation here. So -1, negative correlation. But if it has a very weird shape, irregular shape, then there's no correlation. That means that whenever you do the prediction or the model training, you might not want to include them if you try to train certain attributes. Okay, so that's the basic idea. So this This picture here shows you that what is the rough correlation between two attributes if the scatter plot shows certain trend here. So in this case, just now for our case, so I do the scatter plot for all the attributes. For example, the soil temperature for sensor node 2, temperature, and then temperature. This one is the ambient temperature, and then the humidity 2, and so on. So based on this scatter plot, you can actually see that, okay, for example, if you want to predict what is the you might want to use if you want to predict what is the temperature, so maybe you can refer to this and see what is this. Okay, this is soil humidity 2. So maybe if you want to do prediction for the temperature, you might want to consider include soil humidity 2 into the prediction. Okay, so for example, if you want to do the prediction for temperature, humidity, same. And then if you want to do a prediction for water level difference, so you might want to use the water level difference of the sensor node 1. So this is the basic idea on how you try to read into the scatter plot. Okay, so for example, in this case, on the soil temperature and the humidity, so the scatter plot just goes everywhere. So if you want to do prediction or training model for prediction of humidity, then it might not be useful for you to include the soil temperature because the correlation is too low. So include of the soil temperature into prediction is not going to help. Okay, so definitely when you try to do the machine learning or even DNN, try to do the scatter plot first, get a sense of idea on what kind of attributes or what kind of attributes or input that you wish to use when you do the training. Okay. So then after you get the basic idea of your data, so then you have to prepare the data for the training. So what kind of preparation that you have to do? One of the very common problem that you will face when you do data analytics is the missing values. So what do we mean by missing values? For example, in just now case, we have seen that we have many attributes. For example, like water level, humidity, and so on. There are many attributes that we collected for every entries, right? And then because this is a time series, so you collect there's a data for like every 1 hour. So you have like the data, the water level at 1 p.m., the water level at 2 p.m., 3 p.m., and so on. And you have the input for every attributes. But when we play with the data, sometimes or most of the time there will be missing value. For example, you have the water level at 1 p.m. and 3 p.m., but you have missing value on 2 p.m. So what will you do? So there is a multiple option or multiple method that you can go with. The most simple one is definitely drop the missing value. So you discard all the value for 2 p.m. even just because you don't have the attribute for the water level. So then you discard everything, includes the soil humidity, the ambient temperature, everything, because you already have a missing data. So you just use drop NA. Okay, and then beside drop NA, we can also use drop. For example, just now example, I said that we have a missing value in the water level. So maybe, just maybe, you don't want to use water level during your training anymore. So just drop the whole row or the whole column. It depends. So you have to specify it when you use this drop. So whether x is equal to 0 or x is equal to 1. So another way, the third way is actually fill NA. Fill are not available. So this comment actually fill the missing values with a specific value. For example, you can fill it with a median, fill with a mean. So 3 different methods that you can use, but you have to choose and juggling around and compare and think thoroughly which method actually works best for you. For example, in time series, if you simply just drop the whole entries for 2 p.m., it might not be beneficial. So maybe you don't want to consider drop NA. You either use drop or fill NA. So depends, it goes from case to case. So you have to really think thoroughly. So data cleaning. So beside data cleaning, when we talk about the preparation of data for model training, we also have to think about feature scaling and imputer. So imputer is actually a very handy class in scikit-learn that take care of missing values as well. Similar to just now we mentioned that we can use fill NA. So imputer is actually something similar where you can use it to feed the data. After it learned about the data, then it can use the computed median or mean to replace the missing value. So this is imputer, very handy tools. And then also feature scaling. So what is feature scaling? So in today's example, let's go back to the first. Okay, let's go back here. So in our example, we have a water level, humidity, Lora SNR, RSSI, different units, different range. So the range vary greatly. You can see the max is negative 157. For humidity, the max is 81%. So this variation or huge difference between the range is actually not good for model training. So in order to help the training process, actually have to do feature scaling. So feature scaling means that you fit all the data into one range, for example, from 0 to 1, min max. So there are two most common methods that we use when we talk about the feature scaling, which is min max scaling and also standardization. So look into them, learn the difference, and then choose what works best for you. And so that's about imputer and feature scaling. Then the last part that I wish to talk a little bit about in the preparation of data is the transformation pipeline. So in the previous slide, we have seen what is imputer and what is feature scaling. So when you have a lot of transformation steps, it is actually beneficial. You can do it in the pipeline format. So pipeline actually help you with that. So it helps with many data transformation steps that need to be executed in the right order. So in this example, first, we will try to fill the missing values using imputer. Then after all the missing values are filled, and then only we will conduct the standard scaler. So you can see that in this example, I use a pipeline to do two steps of transformation, imputer and standard scaler. So using this simple command, you run two steps of transformation and then in the right order. So for example, if you have categorical data, and then you want to do one hot encoder, so you can include another step into it. So pipeline is a very useful tool for you to organize your transformation steps here. Okay, so after you have got the data, you visualize, learn a little bit about your data, you prepare data cleaning, you prepare your data, then the last step is do the model training. So model training is very simple. In ML or machine learning, there are many types of machine learning. So we have supervised learning, unsupervised, semi-supervised, reinforced learning. Different type of method that you want to use, and depend on the application, on the case. You might want to choose a different one. For example, if you want to go for supervised one, and then for regression, use it for the housing price prediction. This is a very common example when we talk about tutorial in machine learning. For classification, you might want to use it for the image classification. So all these different methods have a different use. So make sure to learn about them if you have a very specific use case as well. So actually, in data analytics, model training is actually the most simple part. So as you can see, if you want to do the model training, you just have to use a few code. So on the slide here, I have shown you a few codes. So you just have to call the linear regression, fit the linear regression on the training data for it to learn, and then after that, after it had learned, and then you just use the linear regression that we have trained to predict it on the test data, and then with it we can check on the performance of the model on RMSE. So this is the RMSE. So you can see the performance of it, and then basically, ta-da, the machine learning is done. Just a few simple commands, and then you're done with the machine learning part. So it is a common belief for engineers or researchers that when we do the data analytic process, actually 90% of the time is spent on getting the data, data visualization, and prepare the data. And then only like 10% of time is spent on the actually training process. So of course, after the training process, you still have to do this hyperparameter tuning. For example, what is the learning rate? What is the cost function that you want to use? But in today's class, I just want to brief you guys through a very simple example or simple flow process of machine learning. So we are not going to touch about that, the hyperparameter tuning, but that's definitely something that you wish to look into. For example, on how do you get the learning curve of your model to see the learning process? Do they has the high bias, low bias, and if the example shows that you have a very high bias and low variance, what will you do? What is underfitting, overfitting? So these are some very important things that you have to learn as well. But in today's class, because we are just going through the basic flow of machine learning here, so I'm not going to touch too deep into that. Okay. Beside that, there's actually a better evaluation method that we can actually use, called the cross validation. Also, sometimes we call it the k-fold cross validation, where it actually randomly split the training set into, in this example, 5 subsets, because this 5 is denoted by the k. So 5-fold cross validation, it will be 5 subsets. If you have a 10-fold, it will be 10 subsets. Okay, into 5 subsets called fold, then it trains and evaluates the ML model five times. So the model is evaluated 5 times. We have like 5 performance metrics, and then after that, we can average it. So basically, you can see better, because when we do data analytic or machine learning, we have to split the data into training set and data set. Usually, the proportion is 4 to 1. So 80% is for training, and then 20% is for the test, for you to test out the prediction to see how it performs. So k-fold actually do that 5 times. So this figure show you how it actually does it. So this is k-fold cross validation, something that you might want to consider when you do your own machine learning as well. So after you already have your machine learning model, then we have to evaluate its performance. So these are 4 commonly used key performance indicator, which is the mean absolute error, the mean square error, the root mean square error, and then the R square. So most of the time, you see people commonly describe how their model perform using the root mean square error, which is the square root of mean square error. It measures the standard deviation of the residuals. So this RMSE and MSE are the 2 most commonly used one. So and then R square as well, because when you do your model, some people might prefer R square. So these 4 are the commonly used performance indicator. And then, so when you try to plot it, so I have shown you one example here I show you one example on how to plot the performance of the machine learning for sensor node 1. So this title and this subtitle here is actually done using the markup language. So something very interesting that you may want to look into. I don't know. Okay, so using this command, I actually plot a graph to show the prediction versus the real values. So in some of the code I showed just now, the complete code give me this performance after train the machine learning model. So you can see that the blue lines is actually means the perfect prediction. So the closer the red dot to the blue line, the better the performance here. So on the left side is actually the performance of the machine learning model in predicting next hour groundwater level or water table. So you can see that the red dot is very close to the blue line. It means that the performance is quite good, despite a few outliers here. So on the right side is the performance of the model in predicting next day. So 24 hours in the future, the water table. So you can see that the red dot is scattered around a little bit, albeit still close to the blue line, but it's not accurate. So definitely I still have to do some tuning to improve its performance here. So for this example, I give you what is the RMSE of the ML model, which is 7.44 for the next hour prediction, and 27.46 for the next day prediction here. So this is a very simple way for you to shows how to plot a graph and show the performance of your ML model. There are definitely a few other methods that you can still use, but this is the method I use in my example today. So that's all from me on this simple Peat data analytics coaching. So thank you very much.